Everyone, I wonder if I could take a second run, 'cause I carry on getting sad and getting stuck. What I wouldn't give for a life that doesn't suck. I'm a moving target.
Hello everyone, in this video we're going to explore the Earth's internal structure. Welcome to another interesting episode. The last video was the external structure, but this video will be looking at the Earth's internal structure. Now, how is the Earth's internal structure? What does it look like? The Earth's internal structure consists of three main layers, which is the core, the mantle, and the crust. Meanwhile, the core, the mantle, and the crust are further divided into the inner mantle, outer mantle, and the inner core and the outer core. Then we have the crust. The crust is the upmost layer that covers the Earth's surface. It is deep into the Earth, while the mantle is the layer immediately after the crust, while the outer core and the inner core are also part of the core but separated. The inner core is the hottest part, while the outer core is the covering of the inner core. So now, about enough being said and done, let's now look at how many parts all this crust covers on the Earth's surface. The crust is very, very thick, and it's the normal surface where we can call the lithosphere, the outmost part where you see where we match, where all activities are carried on, while the mantle is just directly under the core. The outer core and the inner core are the deepest part, and they are the most hottest part in the Earth's internal structure. Now, the crust is 70 kilometers deep and 43 miles thick, while the mantle is 2,900 kilometers and 1802 meters thick. The outer core is 2,300 kilometers and 14,000 miles thick, while the inner core is 12,020 kilometers and 760 miles thick. All these are figures that tell us just exactly how we need to be seeing these topics. But now let's invite a professor from New York to give us more insights on this internal structure of the Earth.
It had been common belief that there are just 6 continents on our planet. These are the well-known Eurasia, Africa, 2 Americas, Australia, and Antarctica. But at the end of the 1970s, scientists made a sensational discovery by identifying 2 more continents under the Earth's crust at a depth of between 2,500 and 3,000 meters, or 8,200 to about 9,840 feet, each of which is 100 times higher than Mount Everest. These findings can offer some insight into what happened on Earth billions of years ago. This could potentially pose a great fire danger to all of humanity. However, over the more than 30 years since their discovery, scientists have only managed to slightly raise the veil of secrecy over these underground formations, nicknamed for their soft, lumpy shape, the blobs.
We know much more about the surface of the Sun, Moon, and Mars than about what's happening under our feet,
states Paula Kohlmeier, a researcher at the University of London. This is due to our limited ability to study the depths of the center of the Earth. So, what are these blobs like? Are they really continents? And what role do they play in the fate of our planet? One of these blobs is located under the Pacific Ocean, and the second under Africa and partially under the Atlantic Ocean. They are so large that if they were on the surface of the Earth, the International Space Station would have to fly around them. They were found using the seismic tomography method, which was new at that time. Anomalous zones slow down the movement of seismic waves. Hence, their technical name is Large Low Shear Velocity Provinces. Moreover, they presumably consist of rocks, like the surrounding mantle, but have a higher temperature and mass. Exactly what kind of rocks they are dense and heavy or porous lava as the Earth's layers above has also not been established. The question of the density of the underground continents is the main focus for today. Most people know about the tides of the ocean, but not everybody has heard that the cosmic forces that cause them also cause the Earth's crust to rise and fall twice a day with an amplitude of up to 40 centimeters or 15.7 inches. Scientists noticed that the oscillations above the blobs are much stronger, which led to the assumption that the underground continents are much less dense than the surrounding matter. What is their connection with the rest of the planet? At first glance, the Earth's structure is simple. It consists of the continental and oceanic crust, the upper and lower mantle, together accounting for up to 70% of the Earth's mass and more than 80% of its volume, and the core also consisting of two parts, the molten external core and the solid internal core. Also, the crust is divided into lithospheric plates that drift relative to each other. But according to scientists, this wasn't always the case. According to Scott Wattam of the University of Texas and his colleague, at the very beginning of its existence, the Earth was covered with a monolithic crust, similar in structure to the upper layer of the Venus lithosphere. Michael Brown of the University of Maryland at College Park compared the crust of the period to the lid on a pot whose contents were slowly heated. This hypothesis is supported by the most ancient continental rocks, the so-called grey gneiss found in the Western Australian Shield. It turned out that they formed under extremely large mass swings in temperature and pressure and have an unusual isotopic composition, which is possible only if they have long been under the cover of the Earth's crust. But we must also understand when and why this cover was ripped off so that the crust split into plates. The opinions about this differ. Some believe that this happened almost immediately after the birth of the planet, while others believe that it occurred only several 100 million years later. Another proposed alternative is that the cause is an external factor, the impact of a large asteroid, comet, or even a collision with a space object called Theia, from which it's believed that the moon was formed. But Wattam believes that the movement of lithospheric plates started due to the internal processes of the Earth. In support of this, he and his colleagues cite an unusual hole in oceanic basalts in the Caribbean, which appeared about 100 million years ago due to the hot flow of the molten mantle rocks rapidly moving to the surface. Simultaneously with its appearance, the tectonic plate on which it was located began to sink under the neighboring ones. It turned out that the formation of such structures is quite capable of splitting large sections of the crust into plates, since the emerging magma weakens the rocks around the hole, turning it into a sort of funnel. The required condition for the formation of such funnels is the low temperature of the crust in this area. Geologists from the University of California at Davis also studied the question of the rising of hot rocks from the core of the planet to the surface and concluded that it took place before the collision of the Earth with Theia. They gathered together data on geological samples from the Hawaiian Islands, the Balleny Islands in the Antarctic, Iceland, and other regions where these rocks made their way through the crust in the form of lava and cooled. Samples contain ancient isotopes or types of atoms, such as helium-3, which were formed during the Big Bang. Taking into account the zigzag nature of the magma plumes in the Earth's mantle, the scientists tracked the way in which rocks with primary isotopes reached the Earth's surface and thus found a connection with the anomalous continents in the area between the core and mantle. That is, according to these studies, the blobs are directly related to the beginning of the tectonic process, due to which the Earth's magnetic field was also formed by the transfer of thermal energy from the depths of the planet to the surface, which means that it also contributed to the formation of life on Earth. Otherwise, our planet at that moment would resemble Venus with its super high temperature and atmosphere, consisting of sulfuric acid and carbon dioxide. A new breakthrough in the study of underground anomalies was presented by one Maria Chekmistrenko from Oxford University in her 3D map of the continent under Africa. Her representation looks like a tree whose roots go to the center of the Earth, and numerous branches reach its surface right where the locations of active volcanoes are. Scientists have so far refrained from definite conclusions, but suggest that the underground continents stimulate volcanic activity on the planet, and in particular, contribute to the emergence of active volcanoes that form chains of islands, such as Hawaii. They appear to also be responsible for several super eruptions that happened millions of years ago and almost erased all life from the face of the Earth. As far as the origin of the underground continents, there's also no definitive answer. Some researchers believe that they could have formed when the basalt, of which the Earth's crust mainly consists, sank into the depths of the planet due to the high pressure at the junctions of lithospheric plates. As they moved deeper, these rocks, under the influence of even higher pressures and temperatures, encountered various reactions. Upon exit, perovskite calcium silicate was produced, which is considered the third most abundant mineral in the Earth's mantle, at a depth of more than 660 kilometers, or about 410 miles. It's technically extremely difficult to study its properties, since the mineral is stable only in the Earth's interior. But scientists still succeeded as a result of a challenging experiment. The results showed that areas of abnormally low wave velocity are areas with moderate inclusion of processed oceanic crust. However, this result contradicts the opinion of scientists who consider the underground continents to be the cause of the appearance of lithospheric plates and associate them with the hardening of the ancient ocean of magma on the surface of a young planet 4.5 billion years ago. Probably, the truth, as always, is somewhere in between. As for the future, scientists predict the unification of the currently existing continents into one supercontinent, as well as the possible death of all life on Earth due to the eruption of the supervolcano Yellowstone caldera, which has woken up 3 times in the past, and this occurs about once every 600,000 years. The last eruption happened just 640,000 years ago. If the blobs are related to the movement of lithospheric plates and volcanism, then they will most likely be involved in these events. However, all of this is just an assumption. According to scientists, despite the fact that the underground continents are one of the largest objects inside the Earth, we know almost nothing about their nature, origin, age, or functioning. Each new day can bring new discoveries, such as the discovery of a lost continent under Europe, which we'll discuss in one of the next episodes if we get enough comments under this video. If you like the video, give it a thumbs up, subscribe to the channel, click on the bell to enable notifications of new videos, and don't forget to recommend us to your friends.